Hello there, I'm Cillian Kieran, and I'm here to talk to you about the possibilities of privacy as code. I'm really excited to share this session with you, and thank you to the team at TROPT, of course, the Rise of Privacy Tech. We're huge supporters, and we're excited to be here to share a little bit more about the work that we've been doing at Ethyca over the past 3 years. So in particular today, I want to talk to you about the work that we've been doing on an open source project called Fides. And that represents an opportunity to bake privacy directly into the tech stack for any business in any category. So specifically around privacy as code. So with that in mind, I've got several parts to our session today. It's quite dense, so I'll go as quickly as I can and hopefully leave room for questions. Please feel free to ask anything in the comments, and I'll do my best to follow those also. So in particular today, what we're going to do is, first of all, give you a sort of view from the Ethyca side as to what we believe are the challenges related to trust and privacy in software development, and therefore our approach to how we attempt to solve these. After that, I'm going to tell you a little bit more about Fides, and what it is, how it works, and that's going to lead us into the benefits of this approach, which is what we call privacy as code. I'm then going to give you a glimpse into the possibilities, and more than the possibilities, these are things that we're actively working on that Fides will support in the future, so sort of demonstrating the capabilities. And then finally, we're going to round out the session with a real world example. So I'm going to get out of this presentation. I'm going to open up a text editor, a demonstration environment, and show you an actual example of these tools being used in the real world. So let's dive right in. The first thing that we want to talk about is really trust and privacy in software development, right? So what are the challenges there? We all talk about it. We talk about the idea of sort of privacy tech and how it influences software design. And of course, privacy by design is a concept. But what are the challenges that we've seen? Well, so at Ethyca, we start with this principle. And I actually think that anybody watching this, the entire audience here at TROPT, I'm sure you all agree with this. Privacy should be a feature of every tech stack, right? We all talk about privacy being a fundamental human right. Therefore, it should be just built into every system. The challenge, though, in practice, right, is for most developers, and I say that, being conscious that there are many developers that care deeply about privacy, but for many, the experience of privacy is friction and complexity, right? It's the sort of GRC function, the governance, risk, compliance, risk mitigation functions, asking the developers to change the way they work or conduct new processes in order to better mitigate or manage risk or demonstrate compliance or that you can trust the system's behavior. That's a problem in an environment where we want trust or privacy to be a feature of a technology system. So where does that issue start? Well, the way we see it at Ethyca is through the lens of the software development lifecycle, or the SDLC, this sort of virtuous cycle for how we build software systems in the tech world, right? So that is to say, you effectively design them in terms of the technical scope of what a system will do. You eventually code it. You might test it. You might test it very rigorously, and eventually you'll deploy it. And of course, when we think of venture-backed technology, they start from this agile universe where we try and build the smallest version of the system and get it to market as fast as possible. And once we do that, of course, we hope that we'll accumulate customers or users of our technology systems. So growth ensues. And that's typically the point at which most organizations start to think about privacy, or you could say governance at large, right? So all forms of governance, including privacy. You've accumulated some user information. You now have a risk here, and you've got to address that. More often than not, the approach, of course, is to ask very clever policy and privacy experts to think about how we address that now existing risk. And so we'll ask legal and privacy experts to think about data discovery and data mapping, consent, data subject rights. The list goes on. Privacy reviews, protection impact assessments, data minimization, all very important things. But there's one common theme here. The ask of when these are applied for most organizations starts after you've already accumulated data and the risk has started to become real, right? That's the challenge. And so the question that we've been asking ourselves for more than 3 years since we founded Ethyca is, how do we change this? How do we essentially shift left, right? How do we move privacy into the heart of the software development lifecycle so that instead of it being something that is ex post, it happens after the horse is already bolted and the data is already getting in there, how does it become ex ante, meaning a part of the system from its very inception, so that we have privacy as a feature of our technology systems? Another way to think about how we want to approach solving this problem is the sort of tech stack itself, right? We're all familiar with this. You've got typically a front-end language or framework like React or Vue or Angular or JavaScript and TypeScript generally. You might have a back-end language like Python or Scala or Java. You'll invariably have databases that store information from those applications. You might have a version control system that sits behind that to manage the code that's being written and deployed. And then infrastructure as code typically is a language used to describe the actual deployed infrastructure in the cloud. Privacy tends to sit sort of asynchronously and alongside that, right? In some very sophisticated organizations, they're increasingly trying to insert this into the software development lifecycle, but it's challenging. The tools don't exist. So instead, privacy and governance becomes this sort of a parallel process, right? Governance, manual workflows, risk evaluations, privacy reviews, auditing, continuous meetings. And so when we say privacy as code, we quite literally mean privacy as code. We mean a layer of technology that accompanies the rest of the tech stack that should be low friction and effort for developers to implement, that essentially lowers the bar of entry so that every developer can deploy these tools and ensure that governance becomes part of the tech stack, right? So that you are proactive, that you can be dynamic and responsive to new policies or governance changes that the organization needs to adapt to, and lower that friction in the software development lifecycle. And so that's the approach that we've been very focused on for a very long time at Ethyca, mostly building in secret for 3 years until we launched in the open source tools in November of this past year. So our passionate belief here, of course, is that an open source standard for privacy as code can solve these problems. And what I'd like to do now is show you that tangibly and give you a sort of, hopefully, a view of what we think will happen in the future. So to start with, what is Fides? Well, Fides, the name comes from the Roman goddess of trust. It's an open source description language and a set of tools that allow you to add privacy directly into the CI pipeline, so the continuous integration pipelines that developers use, and also into the runtime, so the deployed or production environment where data is actively being processed and queried. Fides is completely open source, therefore it is free. It's both a language, which we'll talk about in a moment, and a set of tools. That language is licensed under the Creative Commons, and the tools are licensed under Apache 2. The features that make Fides so powerful are pretty simple to understand, right? There's a developer-friendly language, so we would call that a lightweight description language that allows you to describe data. For those that are familiar with the concept of infrastructure as code, it's not dissimilar, right? Infrastructure as code, languages like Terraform, allow developers who might not know the nuts and bolts of what a cloud environment is doing. It allows them to deploy databases and application infrastructure or hardware without knowing the underlying sort of nuts and bolts of how they work. In the case of Fides allows any engineer to very quickly describe the privacy behaviors and characteristics of their systems with minimal knowledge of the underlying regulations. So they're able to declare what their system is doing in a way that allows everybody else in the organization to have context so we can manage it. Those tools that sit on top of the language integrate directly with existing software that developers use. So it integrates with Git, which is a sort of common source control for most engineers, and with their CI pipelines. And that means that you can automate evaluations or privacy checks in that pipeline. Because of this, you then have visibility of where data is across your sort of runtime or production environment. So that means that you can start to write automated privacy tasks. So automating subject requests across all of your databases and data infrastructure becomes very easy. And those are then supported by tools that allow you to de-identify data. And there are various ways in which you can configure those before you use that information in any analysis tools. So these are just some of the features of Fides. So as I mentioned, Fides is backed onto a language. We call it Fides Lang. It's a description language, and I'm going to walk you through in a bit more detail in a moment. But at a high level, it supports the common constructs or concepts of the GDPR, the CCPA, the LGPD, and it was closely reflected as a standard in ISO 19944. So we wanted to make sure we would comply with things like the ISO standards, as well as common regulatory frameworks. And its goal is to be able to describe both privacy concepts as well as any other governance models. So the key thing to think about here is it's essentially allowing you to create context on any type of sensitive or critical business data that you might want to govern in the future. Now, I'm going to jump out of this document for a moment to show you the taxonomy a little bit more closely. So we've got here what we call the Explorer. This is publicly available. I'll share links after the presentation. And this will just allow you to get a bit of a feel for what's actually happening. So the Explorer allows you to see the structure of the taxonomy. The taxonomy is structured into 4 parts. So you have data categories, data uses, data subjects, and data qualifiers. So data categories are what they sound like, right? They are categories of data. They can be personal, non-personal, derived, provided, identifiable, non-identifiable. They might relate to business operations of a system and not have anything to do with a human being. The key thing about data categories is this is extremely extensible. So a large developer team that has very particular types of data in its organization can extend this to support its organization's governance needs. But what's important here is it's extendable, meaning those primitives at the top are common or uniform. So you end up with an interoperable way to describe data across any business system. So data in one business that might flow to a third party, provided they're both using FIDES to describe their data sets, can enforce or govern them consistently. Data uses is exactly that. It's the way in which we use data. You can think of it as purposes of processing or categories of use. So you can see there are common constructs for how data might be used in an organization, particularly sensitive information. Data subjects is exactly what you would expect. It's the enumerated list of the types of subject data that might be in there that might need to be policed or managed or governed in different ways. And then there are data qualifiers. Now, data qualifiers is a flat structure. It's a little hard to see here. So what data qualifiers are essentially is the ability to confirm or declare the degree of identifiability that a set of data represents. So for example, we might have completely anonymized data. We might have de-identified or pseudonymized and unlinked data, or we might have data that is aggregated that represents some risk to a user. So between data categories, data uses, subjects, and qualifiers, you essentially have an ontology that allows you to describe consistently the types of data in any system and therefore govern that system. And we'll show you an example of that concretely in this presentation shortly. So I'm going to jump back to our document now that we've just covered the basics. On top of the language is these sort of tools that allow you to power and use the language itself. So on the left side, we have FIDES control. FIDES control runs essentially in the code management environment. So think pre-deployment. It essentially manages policies that you might want to govern or enforce. It also manages the metadata layer that allows you to see what data is flowing where in the organization and enforce policies in your CI pipeline. FIDES Ops is a runtime or deployed environment tool, right? Meaning that it runs where data is being processed and queried, and allows you to construct complex privacy policies for enforcement, like we might want to erase certain categories of personal data after 3 or 4 days of use, ensure that that's done consistently across all distributed systems. Perhaps we want to respond to a data subject request, and so we'd like to construct that policy very carefully for what types of data can be returned to a user or might be erased from various systems over time. So the benefits of a privacy as code approach are probably or hopefully starting to become clear as we just go through this. Because these tools are baked into the software development lifecycle, if we go back to that virtuous circle, we add some new labels that we think about in governance. We now have the ability to very easily declare or allow developers building things to easily declare what types of data they're processing, for what purpose, and where it is. We have the ability to evaluate those conditions as they write that code to ensure that they're not doing anything accidentally or intentionally that might disagree with our policies or break the trust that we hope we have with our users. And it allows us to enforce that. And finally, we can audit it. We can generate reports that demonstrate that throughout the software development lifecycle. And because it's happening at the software development lifecycle, it's creating a very detailed metadata map for where information is flowing in the organization. So managing a map manually in terms of spelunking and databases to look at what data might exist there becomes a redundant effort, right? This is now something that's happening from the moment you build systems. And because of that, we can enforce any runtime task or operation. So we can mitigate risk in the software development lifecycle, right? We can truly reduce it. We can generate an audit trail of those decisions, and we have a really consistent data inventory. And because of that consistent data inventory, if you think about it, what we ultimately have is context, which is the challenge that faces governance at large, is detailed context about what is happening in these systems, where and how, so that we can then enforce or control that. And FIDES provides both sides of that. A privacy as code approach, in fact, provides both sides of that context and also control over those business systems. So, of course, the possibilities here are truly endless. What I want to give you a glimpse into before we show you a real world example is the things that we're working on in the future and what FIDES will support imminently. So something that I know has come up even today in earlier sessions is this idea of interoperability or governance as a standard. So one of the challenges we'll all identify with is if you're working in any business at any sort of scale, you've essentially got third-party sub-processors or SaaS providers that are receiving data from your systems to perform a business task. Of course, that creates a risk in terms of that data flowing there and how you govern it or manage it. There's a sort of opaque process that occurs between those systems currently, not because anybody's trying to hide it, but those systems aren't designed to speak to each other. When you use a privacy as code standard that is open source, freely available, and readily agreed upon, everybody is describing their data sets in the same way. There's no proprietary information in that. It's just a description of what information is flowing and how it might be used. That now allows us to create a standard format for governance or enforcement across any system, right? We as an organization can have our mandate or policies. We ensure those trickle out to our third parties related to our data. Because of this, we can govern things that are previously very sort of labor intensive and manual. So the concept of protection impact assessments or privacy reviews. Some organizations that are really forward thinking in the space of sort of privacy by design are already developing very detailed privacy review programs for their engineering teams. Those are valuable and vital, but every engineer will tell you they're also very time consuming, resource intensive, and friction filled. They delay what is typically a very agile process. Because you can now create a policy and effectively evaluate it while engineers are writing code and generate a report from it, you can start to enforce decisions that are low risk there before a human expert needs to review them. So you sort of sort the really critical issues from the low risk stuff and allow that to proceed very quickly. And all of that is automated with an audit trail. So now you have governance in the CI pipeline, right? You have the ability to actually enforce these checks before you deploy anything. And a really concrete example of this, we are all aware of the Facebook FTC consent decree. Facebook's defense there is the misuse of data was ultimately accidental in a large organization with many moving parts. You would never suffer that problem. You can ensure that you can enforce a policy in the CI pipeline proactively before code is deployed and misuses data accidentally or intentionally. You get to the next point, which is input, output, or IO annotation. So we all talk about data lineage and the need to be able to achieve fine-grained enforcement. So identify a specific data analytics tool or business intelligence pipeline and ensure that it's only touching the right types of data for the right purposes as approved by our end user in terms of their permissions. It's very difficult to actually do this fine-grained enforcement because knowing the lineage of data through many systems is deeply challenging, and most organizations ultimately rely on a static cataloging tool and a huge amount of analysis and labor. These annotations are input and output, the privacy as code annotations, meaning that a single service describes exactly what data it's receiving from where and what data it's exiting and to where. And this allows you to have very detailed lineage at the individual field level for every API. That leads to API contracts. So today, we're all familiar with the need for DPAs, and they are absolutely vital. But if you consider their purpose, they're sort of not quite enforceable, right? So a DPA becomes a legal negotiation between two parties, but it's very hard to evidence that in their business systems. APIs that developers connect technologies together with already have very detailed documentation. We can annotate those now with privacy annotations. So now APIs in the literal sense become a contract for what systems will promise to do with your data and what they may do with that information. That can become enforceable at the API level. And that leads to the final sort of the zenith of what we want to accomplish, which is semantic access controls. We want to be able to enforce data minimization to the smallest amount of information, right? So individual fields of data restricted to specific purposes of use based on conditions set either by the organization or permissions granted by the end user, so that we can do this today or in the future if regulations change. We're able to write new rules or conditions that are enforceable across all business systems. So these are the possibilities in the future that exist for FIDES as we work on it over the next couple of years. I'm going to get into now a real world example. I've talked a lot about enforcing policies in the development pipeline. And so rather than talk about it, I'm going to start to show you this. And I apologize, I should point out that all of the comments and questions that might be coming up are on the left screen. And so I may be missing some of them, but I'll try to get to them in a moment, I promise. we'll talk about this real world example, and then we'll try and tackle some of the questions that are here for everybody. So in particular in this one, what I'm going to show you here is sort of a typical deployment of these tools. I guess to level set, what you're looking at here is sort of a very abstract organizational map of how business systems might work commonly, but they're not always the same for every organization. So if we think from the top down, right, we've got this sort of GRC legal executive team. They're ultimately responsible for determining the business policies and goals of the organization and for writing those policies, right? So that's that top row. The next row is maybe the business unit owner, or it might be what you might call a product manager, product owner, or feature owner. So someone who's responsible for understanding how data might be used and writing some additional policy information. And then you've got engineering and technology teams who are responsible for designing, coding, and deploying things. So the FIDES control tool is available to all of these teams to perform different tasks. In the case of the legal function, they can write policies, and I'll show you that in a moment. They can write a policy that's then enforceable. For business owners, they can describe context for how those systems are being used. And then for engineering teams, they can actually describe the types of data that they're handling so that those can be checked before they're ever deployed to the right side, to the runtime environment. So effectively, the ability to check what is being built against organizational policies before it ever touches any real data and creates any real critical risks. So in this demonstration, we're specifically going to be talking about that example. There are also tools available in the open source projects that support runtime tasks like data subject request automation, for example. So with that, what we're actually going to do here is run a privacy check in a CI pipeline. So at a high level, what are we trying to accomplish here? Well, we want to describe our systems, right? So if I put my developer's hat on, as a developer, I want to be able to provide enough information so that we know exactly what our system is doing, what task it's performing, and with what types of data. So that is, whose data, what data about them it is, where is it, how are we using it, right? I want to be able to check that what I'm proposing I do in my code is compliant with the organization's policies. And if it is, I continue. And if it's not, I want to update the code that I'm working on to comply with the organization's policies. So what we're going to do is those 4 steps. We're going to look at how we describe a system very quickly. We're going to dig into the taxonomy a bit more deeply in terms of the 4 facets of what it represents. We're going to actually check in some code. And then we're going to see what happens when we fail, when we incorrectly try to commit code that does not meet an organizational policy. So again, it's going to get a little dense, so I apologize in advance. Please do put questions in. I promise I will do my best to leave time at the end of the session to answer those. So we're going to get into VS Code. Hopefully you can all see that. I'll zoom in a little bit more. So just to explain what you're seeing here at a high level, first of all, this is not deployed anywhere in the cloud. This is running locally on my computer. So this is a demonstration environment in which I'm running essentially a version of FIDES. So the control server, the CLI tools that are here that you see here. And for those that are maybe slightly less technical, what you're looking at is an IDE or a text editor that developers work in, right? So this is where they would write code and potentially commit that code to a central repository where it can be reviewed and checked before it's deployed into a production environment and actually touches data. So what we have at the top are 4 documents. These are all FIDES annotations documents. So behind these is essentially a fictional e-commerce system, okay? So we have built an e-commerce system that's able to collect some user data in a checkout process. So this first file we're looking at here, you can see is the dataset file. So this describes the database that's powering our e-commerce system. Now it's a very simple e-commerce system, okay? So there are only 3 tables in the database. There's a products table, there's a purchases table, and a users table. And if I expand out the users table, I can see here that there are several fields, right? There is a created at field, an email field, first name, ID, last name, password, etc. What you'll then see is the sort of substantive FIDES annotations. These are where you see data categories, for example. It's declaring that the created at field is data related to systems operations, whereas the email address is user provided identifiable contact email address. And so if we go back to our taxonomy again, this is where we're using the taxonomy to describe that a field of data is user provided identifiable contact email, or postal code or zip code or street, etc. So we have the ability to describe exactly what type of data we're handling in a database. So in this case, the database. The other files that we have here, just to go through them in the right order, is the actual system file. Now, for the purpose of this example, we have a single file that describes our e-commerce system. Now, in practice, you might have several files that describe various components of a very large system, right? More commonly, you might have many of these together. When they are, let's call it, compiled by the Fides server, they effectively represent a metadata layer or a view, a sort of compounded view of all of the system behaviors across the organization. So we can see substantively exactly what each service or application or pipeline or tool is doing with what types of data. So in this case, we can see we've described that it's an e-commerce system, a very simple e-commerce system. It has 3 data categories that it's collecting and processing. So it's collecting broadly user-provided identifiable data. So just to explain that, rather than specifying a specific single category, if I go back to the taxonomy, we're just declaring that it is provided identifiable data in aggregate. So it could be any subset of that from there. We're also saying we're collecting and processing user-derived identifiable data, and that we're collecting systems operations data like telemetry information, et cetera. And the purpose or use in this case is singular. It's just to provide systems operations. And by that, we mean it's effectively to provide the capability that we have. And the subject type that we're working on is a customer. It could be multiple. And the degree of identifiability in the data, so how qualified the data is, in this case is identified. It is identifiable information. It directly describes an individual, this data set. So that's our system file. Now, we've got basically a description of our database and a description of our system. I now, as a developer, I'm an enterprise engineer at the team. I've got a good idea. I'm going to add Google Analytics to this simple e-commerce system. So it's a very simple example. So I'm going to create a Google Analytics declaration file we have here. Now, it's worth noting, this looks quite dense because we've got a lot of notes to sort of be comprehensive. But in truth, what you're asking the developer to do is declare a handful of lines that describe a system. So if you look at this carefully, we've got a name, it's Google Analytics, a description of what it does, the type of system that is third party. And then I've stated the categories of information very precisely that I know Google Analytics is collecting, right? Browser history, cookie ID, telemetry, location, user-derived non-identifiable. So that's one purpose, one privacy declaration. The next is deriving user geographic location. So I've said, well, we want to know where users are in the world. And so for this, we're going to collect IP addresses, location data, and some other identifiable information. And we're going to use this to improve our system's operations. Now, a very common failure for developers is they don't know, candidly, that IP addresses are considered personal data. And so they would never identify this as risky information very often from a compliance perspective. So in this case, I'm going to go ahead and I'm going to commit my code. Now, because this is running in my local environment, it's not wired to a CI pipeline. So to commit this, I'm going to run a sort of local command that will allow me to do that. So basically, we're going to just run an evaluation. So what's happening here is it's just turning on Fides control server for me. It's checking all the organization policies in this fictional organization. And it's just a little slow. There we go. It's retrieving all of the policies. It's checking the declarations I've made. And we've got a red flag, a failure. So the code has not been checked in. And the reason for this, it says that I'm attempting to derive a user's geographic location with user identifiable data, and that is not something the organization permits. Now let's dig into that. We have a sample policy, just one for this organization. And it essentially says precisely this, that we want to minimize user identifiable data as an organization, and we reject the collection of any user identifiable data for any of these types of purposes. So essentially what we're saying is if you collect any of these types of data, these data sets that may identify a user to do any of these things, this should be rejected. We don't permit this as an organization. So as a developer, I've got to now go back and make changes to my code base. So I might go and do some research. I might understand the IP address issue. I will probably obfuscate the last octet of the IP address. And now we're dealing with pseudonymized data. So I'm going to update my policy to or my declaration to pseudonymized. And now I'm going to rerun my evaluation. So it's again, checking my code base, checking my declarations against organization policies, and we'll see the evaluation has passed. My code can be committed. It meets the organization's criteria, and it can be submitted and deployed at a later date. So at a very high level here, we have described a system's resources and their privacy characteristics or behaviors. We've given a developer a very simple dot notation language, this user-derived identifiable device, to describe their business system's behavior. And we've created tooling that allows us to enforce those checks even before a system is deployed. That metadata layer that is running through this now gives us a map of what personal information is flowing through each system and allows us to enforce those conditions in the runtime environment, for which we have a whole separate set of tools. So again, just to recap, we've described our systems, we've given that context, and we've been able to enforce a policy we had previously written, and we've updated some of our systems behavior to comply with that, and we've reevaluated our code, it meets our policies and conditions, and we can move forward. So just in conclusion, what we've covered is Ethyca's view of sort of trust by default, right? Trust as a feature of every tech stack, and how we can accomplish that with a privacy as code approach. The work that we've been doing for the last 3 years at Ethyca in delivering FIDES, which was finally released this past November. The benefits of a privacy as code approach to both the GRC and governance function and the entire engineering team. The possibilities for the future, what this will allow you to enforce, and a quick real world example. Now, I'm very aware we've got a lot of questions that have shown up here. So I'm going to try and go back up over some of these very quickly and read them. Apologies, I'm just having a quick look here. So one of the first ones here that I see is Carrie Lenning has asked, won't this just lead to engineers coding around these limits or just classify data differently? Well, it's a really good, both a question or rather a statement, right? In fact, we're already asking developers to describe their systems, right? If you look at most large engineering organizations, they're inserting privacy reviews or asking developers to declare data annotations on their data sets. Right now, that's a human-in-the-loop, labor-intensive process. What we're doing here is putting those annotations directly in the code base so we can evidence it and create an audit trail. And that allows us to identify where failures are occurring and correct them more quickly, right? So you could look at this in two parts. One is a proactive gating mechanism, and the other is the ability to historically look back and identify where there is an issue or a risk and correct it. It gives you the audit trail that the FTC has asked Facebook to create in their consent decree to ensure that they're demonstrating healthy practices in their software development lifecycle. On the point of coding around it, if you use the tools in their sort of fullest form, you effectively couldn't commit any code that doesn't meet the organizational standards. You couldn't deploy or rather commit around it. You could certainly falsely annotate something, but I think then we're getting into like bad actors, which goes beyond maybe certainly where the tools are today, but asks a bigger question about sort of organizational behavior. Our general view would be that developers want to solve these problems. They just don't today have elegant tools to help them do it more effectively. There's some questions around Ethyca has raised around the characterization of aggregated data. Ethyca, I completely agree that aggregated data can be very identifiable. We're not suggesting that it poses no risk. Aggregated data, if you look at the documentation, you'll see it does very much pose a risk, but it's on a relative spectrum to others. And the source for that on our side was the ISO 19944 standards, where they term aggregated data on a spectrum from, between pseudonymized, unlinked, truly anonymized, so no personal information at all, through to aggregated data. There's no question that aggregated data poses a real risk of identification. The question from a compliance and risk management standpoint is the degree of identification that data set affords, and therefore the risk for the organization, if you think of it from a privacy impact assessment perspective. So we're not suggesting that it wouldn't pose any risk for an organization. It might be an order of risk lower than some other data sets. I'm struggling. There are many questions in here that I'm struggling to get to very quickly. And yeah, I think Ryan sums it up there. As an infrastructure engineer, I'll write some more YAML over doing another PI questionnaire. And you say, thank you, Ryan. That's precisely it. And also the samples I've shown are dense because we're showing you a full system declaration. In truth, you're asking engineers to add 1 or 2 lines to a YAML document for, a set of methods that they might be writing. So it's a very small imposition on their effort to generate a huge amount of auditable data and instrumentation about what's happening in the software development lifecycle. Kerry, you had another question related to laws changing. So the taxonomy is not just, I think a better way to think about it is the taxonomy can always change. It's extremely malleable and it's fully extensible. So today, if you were to use the tools, you could ignore our taxonomy and use your own. The tools will still function on that taxonomy, on your own one, I mean. You can extend ours. Obviously, we encourage people to extend the open source taxonomy because we're trying to get to an interoperable standard, right? Something that supports every organization. The whole point of Ethyca is go forward governance as it relates to privacy as code, right? The idea is that we believe fundamentally that regulations will continue. All you have to look at is the Digital Services Act, right? One part privacy, other part market and competition law. Those now require other types of data to be monitored, policed, and policy to be enforced against them, and not always for privacy or personal information reasons. And so if you're looking at this sort of rapidly evolving regulatory landscape of like very complex data-driven or distributed systems, you need a solution to describe all data, not just personal data, and then allow you to enforce new policies into the future. So it's intended very much for that. So I think it would be less about the taxonomy changing, rather than extending, and also the ability to write new policies on top of it. I suppose just as a final word on my side, FIDES is truly open source. It's fully available publicly. You can learn more about it on our website at ethyca.com/FIDES. We encourage you to join the community. There's a Slack community and a set of channels there. We're looking actively for constructive criticisms, feedback, create issues on GitHub and contribute so that we can improve this for every developer. So we get to a standard set of tools that are easily used and interoperable across business systems. That's the ask from our side. We'd love to get your feedback and thoughts on the project in general, and any support that you want to offer in the way of their use or tooling. From there, I'm going to stop. I know there's a lot of questions, so what I suggest I'll do is I'm going to copy those, and I'll go to the hall after this. And if anybody wants to ask any of those questions in real time, I can have them there, or we'll follow up afterwards to answer those. Thank you so much for your time and interest, and I hope to get your feedback in the ethics community or in the FIDES community very soon. Thank you.